Hello, my name is Neel Pandit and I'll be going to 8th grade soon. I have always been fascinated by drones and flying machines. When I was 7 years old, my parents gifted me a small toy drone. And that's where my curiosity about drones began. That curiosity led to me wondering about the science behind how drones actually work. In last 1 week, I worked really hard to create this short film about drones. I learned how to do various things like prompt engineering, AI voiceover recording, image generation, video editing and more. I learned how to use various tools like Nano Banana, Google Flow, VO3 to generate videos, then Canva, Filmora and whatnot. In this short film, I've explained some important science concepts used in drones like lift, aerodynamics, Newton's third law, electromagnetism and more. I hope you enjoy. Make sure to watch till the end.
But how does a drone actually fly?
I don't know.
Let me explain it to you. The four main forces which act upon a flying drone are lift, drag, thrust, and weight or gravity. Let's see what lift means. In drone aerodynamics, lift is the upward force generated by the interaction of the propellers with the air. The propellers suck in air from above and then push it downwards to fly. According to Newton's third law, when the propellers push air down, the air pushes the drone up. This upward push fights against gravity, keeping the drone airborne. The propellers of a drone are shaped like the wings of a plane, which helps suck in air and push it downwards. The top surface of each propeller blade is curved, while the bottom surface is flatter. As the propeller spins, air traveling over the curved top moves faster than air below, creating lower pressure above the blade. The slower moving air below has higher pressure than the faster air above, and this pressure difference pushes the blade upwards, generating lift. At the same time, the angled blade physically deflects air downward, pushing it beneath the drone with force. Together, the curved shape and the angle of the blade work as a team to continuously pull air in from above and drive it powerfully downward. All of this only works if the propeller is spinning, and that job belongs to one of the most clever pieces of engineering on a drone, the motor. Drones generally use brushless DC motors, or BLDC motors, one on each arm of the drone. Inside each motor, there are two main parts, a stationary set of copper wire coils called the stator, and a rotating outer shell with permanent magnets called the rotor. When electric current flows through the copper coils, it creates a magnetic field around them. Each coil can be switched on and off individually, and when switched on, the direction of the current determines whether it becomes a north or south pole. The permanent magnets on the rotor are attracted to opposite poles and repelled by matching poles. So by switching the right coils on at the right time, the rotor is continuously pulled forward. You can see a demonstration of this in the following animation. And just like that, the rotor keeps chasing the switching coils around and around, never catching up, and that is exactly what keeps it spinning. Now that we know how the motors work, here is something clever about the way they are arranged. When a motor spins a propeller, Newton's third law means the propeller pushes back on the drone body with an equal and opposite rotational force. This rotational push is called torque, and it tries to spin the entire drone body in the opposite direction to the propeller. If all 4 propellers spun the same way, these torques would add up and send the drone spinning uncontrollably. So the opposite diagonal pairs of motors spin in opposite directions, 2 clockwise and 2 counterclockwise, canceling each other's torque out and keeping the drone perfectly stable.
That actually makes so much sense now.
This is when I was 7 years old, the first time I ever flew a drone. Sometimes a small childhood gift can become the beginning of a big curiosity. What started with flying a toy drone slowly became an interest in science, technology, and learning how things work. Thank you.